Hello everyone, welcome back. In this video, I will be covering section 3.5, which is implicit differentiation. So earlier in the videos from section 3.1 to 3.4, we saw power rule and then lots of other rules, how to find the derivative of trigonometric functions, and then how to use chain rule, how to use product rule, quotient rule, so on and so forth. So we have been seeing all kinds of functions, and each time we introduce a new rule. So in this case, we are going to see how an implicit function can be differentiated, right? So what is the difference between implicit function and an explicit function? So up until now, every function we have dealt with included one variable explicitly in terms of another variable. So we isolated the y to write y as square root of x cube plus 1. In general, y equal to f of x. Some functions, however, are defined implicitly by a relation between x and y, such as x square plus y square equal to 25, or x cube plus y cube equal to 6xy. So both x and y on one side. So how do we, if both an x and y are on one side, sometimes it is possible to solve for y and isolate the y and write that y in terms of x. That's one way we can differentiate and make it look like an explicit function. But sometimes we won't be able to isolate the y and write that as a function of x, which will, so the problem will be complicated otherwise if you try to isolate the y and differentiate. So in which case, directly differentiating it with respect to x, with respect to one of the variables will be much easier. So that is exactly what we are going to do in this example. If x square plus y square equal to 25, find dy by dx, find the derivative. Find an equation of the tangent to the circle x square plus y square equal to 25 at the point 3, 4. So let's do the first part. X square plus y square equal to 25. Now we want to differentiate both sides with respect to x. So d by dx of the left-hand side equal to d by dx of the right-hand side. Derivative with respect to x. The left-hand side is x square plus y square, where y is a function of x. Keep in mind, y is a function of x. So d by dx of 25. So what is derivative of x square? 2x. What is the derivative of y square? Where y is a function of x. So you have to keep in mind, y is a function of x. So y square actually means function of x, the whole square. So now imagine y f of x to be sin x, or f of x to be x square plus 1. So in which case you will use chain rule, right? So it is outer derivative times inner derivative. Outer derivative is y square derivative, which is 2y, but the inner derivative is derivative of y, where y is a function of x, which is f prime x or y prime, which is equal to derivative of a constant, which is equal to 0. So if we divide throughout by 2, we get x plus y prime equal to 0. So y prime equal to negative x, or y prime by dividing throughout by y, you get it is negative x by y. So we got dy by dx, the slope. Now we have to find out the next part, that is the derivative. We already know the derivative, which is the answer to part A. For part B, we are going to find out the equation of the tangent line. For the equation of the tangent, we need the slope. We need the slope and the point through which it passes, which is 3, 4. The slope is a number which is a derivative at the point where the tangent is drawn at, either the tangent is drawn at the point 3. So we have to evaluate dy by dx at x equal to 3 and y equal to 4. So which will be negative x over y evaluated at x equal to 3 and y equal to 4. So if you plug in these values here, it is negative 3 over 4, which is the slope of the tangent line. So it is now equation of the tangent is y minus y1 equal to m times negative 3 over 4, x minus x1. So you're substituting the point x1, y1 with the 3 and 4, and the slope with the negative 3 over 4. So now if you distribute, you get negative 3 over 4x plus 9 over 4. Then if you have to move the 4 to the other side, that will become negative 3 over 4x plus 9 over 4 plus 4, which is negative 3 over 4x. And this will be 16 plus 9, that will be 25 over 4. So this is written in slope-intercept form. Of course, you can also write the same answer in ax plus by plus equal to c form as well. So this is the equation of the tangent line. So the first part is to get the derivative. Second part is to find out the slope of the tangent at a specific point, and then write down the equation using y minus y1 equal to m times x minus x1. Let's try some additional suggested problems from the exercise. We will start up with problem number 5, which is also a problem in the practice final and the practice exam. So the problem tells us that find dy by dx by implicit differentiation. So also we notice that both x and y are on the same side. X and y are on the same side. That tells us that the function is implicit. So let's do the derivative on both sides. So d by dx of the left-hand side equal to d by dx of the right-hand side. So this is x square minus 4xy plus y square. This is 4 on the right-hand side. Now you differentiate both sides with respect to x. Derivative of x square is 2x. Derivative of 4xy, here you have to be careful. So you have to treat x comma y as a product of two functions. Then you are taking the derivative of product of two functions. So you will treat one of them as u, one of them as v. We know that derivative of the product rule is what? Product rule. d by dx of uv is uv prime and v u prime. You can switch and change the order in this case because they are added. So the terms can be switched. So in this case, we are going to do d by dx of x comma y. So where x is u, y is v. So it is u, which is x, v prime, which is derivative of y, y prime, plus v, which is y, and derivative of u prime is derivative of u, derivative of x, which is 1. So here we write xy prime plus y, which is the derivative of xy. Then next one is derivative of y square. So here you use the chain rule, just like the earlier problem. Outer derivative is 2y, inner derivative is y prime. So here what rule are we using? Chain rule. Outer derivative times inner derivative. Then on the right hand side, derivative of 4, which is 0. So we have 2x minus 4xy prime minus 4y plus 2y prime equal to 0. What are we trying to get? We are trying to solve, or we are going to find y prime. So keep the y prime terms on one side. So I'm going to keep this term on this term, which have y prime on them on one side, and write the positive expression first and then the negative expression, then move the rest of them to the other side. So if I move negative 4y to the other side, it becomes positive 4y. Positive 2x will become negative 2x. Now isolate the y by dividing both sides by 2y minus 4x. So 2y minus 4x. So this will be y prime equal to 4y minus 2x divided by 4y minus 2x, 2 over 2y minus 4x. If you factor the 2 out, 2 times 2y minus x divided by 2 times y minus 2x. So can cancel that. So the answer becomes 2y minus x over y minus 2x. That is the derivative. And we used implicit differentiation technique for this problem. We'll try the next problem where it says practice test number 10. So you know that PT stands for practice test, PF stands for practice final. And if you see stars, they're all homework questions. So let's try the problem x e to the y equal to x minus y, and we are going to use implicit differentiation technique because both x and y seem to be on the same side. So use implicit differentiation. We get d by dx of one side equal to d by dx of the other side. It's x times e to the y. Note that it's a product. Right hand side, x minus y, difference. So in this case, we have to treat one of them as u, x equal to u, and e to the y equal to v, and apply the product rule. So apply here product rule. So we'll consider u equal to x, v equal to e to the y. What is u prime? Derivative of x. What is v prime? Derivative of e to the y. It's not just e to the y, and then times y prime, because we are going to consider derivative with respect to x, and it is chain rule. We are so it is outer derivative times inner derivative. Outer derivative for e to the y is e to the y only. So anytime you differentiate e to the something and then you use the chain rule, the derivative would be e to that something times derivative of something. So if you have a function like this, keep in mind that's the way you do. So it's e to the y times y prime. So we are going to use the product rule, which is u v prime. So d by dx of uv is u v prime plus v u prime. So it is x v prime, that is e to the y prime, u v prime plus v, what is v, e to the y, u prime, that is equal to 1 on the left hand side. Now on the right hand side, derivative of x, which is 1, derivative of y, you just have to say y prime. Derivative of y with respect to x, so it is just y prime. Now we have to move all the y prime terms to one side because the goal is to find what y prime is. So we will move this negative y prime to the left hand side. So it will become x e to the y prime plus y prime. On the right hand side, you have 1 minus e to the y. This e to the y over here moves to the right-hand side and becomes negative e to the y. So collect all the y prime terms, common factor it out, y prime. So it is x e to the y plus 1 equal to 1 minus e to the y. Now we divide both sides by x e to the y plus 1, x e to the y plus 1. So y prime equal to 1 minus e to the y over x e to the y plus 1. So that is a derivative with respect to in terms of implicit differentiation. Here you have to understand that y, keep in mind y is a function of x on the right hand side. Normally when we did the problems earlier, we know that whenever we solve for y prime, the right-hand side turned out to be a function of x. Here, the right-hand side can be a combination of x and y, but with the understanding that y is a function of x. Let's try a problem involving tangent, involving a trig function. Use implicit differentiation to differentiate, find dy by dx, where tan of x minus y equal to 2xy cube plus 1. So tan of x minus y equal to 2xy cube plus 1. So as we did normally, as we do the implicit differentiation, we will consider d by dx of the left-hand side, which is d by dx of the right-hand side. So the left-hand side is tan of x minus y. The right-hand side is 2xy cube plus 1. What is the derivative of tan of something? Derivative of tan of something is the outer derivative, which is secant squared of something, times the derivative of the inside. Okay. So the derivative of tan x is secant square x, which we know from the derivatives for trigonometric function section. So now we are going to do the outer derivative times inner derivative. The outer derivative is secant square, keeping the inner function as is, then times derivative of the inside, which is x minus y prime. Here, it is 2xy cube. What we have to write is, we can either consider this as 2x times y cube or 2 times xy cube. So let me write that as 2x times y cube using the product rule. So d by dx of 2x y cube is d by dx of 2x multiplied by y cube, so product rule. So you're going to treat one as u, 2x as u, the other one as v. So it will be u v prime plus v u prime. So u, which is 2x, v prime, which is y cube prime, plus v, which is y cube, u prime, which is 2x prime. So it is 2x. What is the derivative of y cube? And when you say derivative, it is derivative with respect to x. So it is outer derivative, you are using chain rule, outer derivative times inner derivative. That will be y prime. Plus y cube, derivative of 2x, which will be a 2. So when we write the first one, so we have to write 2x times 3y square, y prime, plus 2y square. Then what is the derivative of 1 though? That is going to be 0. So if I rewrite this, it's secant square x minus 1 times derivative of x, which is 1, derivative of y, which is y prime, equal to, here if you notice 2 and 3, 6 x y square y prime plus 2y square. To y cube. It is 2y cube. All right. Now, we have to collect all the y prime terms. The goal is to find y prime. So collect all the y prime to one side. So it is secant square of x minus y minus secant square of x minus y times y prime equal to 6xy square y prime plus 2y cube. All right. Now, if I group all the y prime term to one side, let me keep them on the right-hand side. Y prime 6xy square. Then I'm going to move this y prime term, the left-hand side one to the other side. That will become plus y prime secant square x minus y. Then what am I left with on the left-hand side? The secant square x minus y. Then this 2y cube goes to the other side. That will be minus 2y cube. Now you common factor the y prime. So y prime can be taken out. Then it will be 6xy square plus secant square x minus y. On the left-hand side, it is secant square x minus y minus 2y cube. Now you divide both sides by 6xy square plus secant square x minus y to isolate the y prime. The 6xy square plus secant square of x minus y. These two cancel out, leaving you with y prime equal to secant square x minus y minus 2y cube divided by 6xy square plus secant square of x minus y. That is the final answer to the derivative. And if you notice this particular problem over here, 32, use implicit differentiation to find the equation of the tangent line to the curve at the given point. It's kind of exactly similar to the example that we did. So you, in the first part of the example, you find out the derivative. Second part, you find out the slope, then find out the equation of the line. So it's kind of similar to that problem for your reference. Hope this video helps, and I'll see you guys for my next video on 3.6, which will talk about logarithmic differentiation and derivatives of inverse trig functions.